There we go. Okay, so last class, we all learned about our 7.1 ratios and proportions. Today is pretty similar. We're still doing ratios and proportions, but now we're focusing on, the idea of similar polygons. Okay, so we have to talk about what that means. So the word similar is an important word. That's like a good vocab word that's fair game for the next test or quiz. Two polygons are similar if and only if all corresponding angle pairs are congruent and corresponding sides are proportional. So far we've done congruent triangles where we've done congruent shapes where all of the angles are congruent and all the sides are congruent. But right now we are going to talk about similar polygons, which is all the angles are congruent, but the sides are proportional. And what proportional means is that there's a common ratio between corresponding pairs of sides. So maybe it's a ratio of 2 to 1. Maybe it's a ratio of 5 to 7. It doesn't truly matter what the ratio is, but as long as there's a common proportion between all sets of sides, then yes, this shape is similar. Okay. Informally, for polygons to be similar, they have to have the same shape, but they could possibly be different sizes. So like that being said, you can't have like a square be similar to a pentagon because they don't have the same number of sides. So that means that they don't have corresponding sides. So they must be the same shape, but they're often going to be different sizes. So I might have like a square that's small and then like a square that's bigger. And those are proportional, even though they're different sizes, but they are the same shape. Okay, are congruent polygons also similar? The answer is yes. And the reason why that is yes is because all of my angles are congruent. And all my sides are congruent, but they are also have a 1-to-1 ratio, which means that they're the same. So like if one side is 5 and the other side's congruent to it, it's also 5, their ratio, their proportion is 1-to-1. Okay. All right, let's see. Okay. Notation, if I have this little it's like a tilde mark in Spanish, and like when you have like a little ñe in Spanish class, this is very similar to that. That little curvy line means it's similar to. Remember, congruent is where we have the equal sign with the little curly on top. But if you have the curly without the equal sign, that just means it's similar to. Okay. The ratio of the lengths of two corresponding sides of two similar polygons is what we call the scale factor. So again, if my sides are proportional, then they have a common ratio, and we call that ratio the scale factor. Okay, we've done a lot of vocab. Anybody questions yet? Okay, the last important thing before we start kind of doing some problems and writing this all out is as with congruent statements, the order of the vertices in a similarity statement is important. So this shows me which angles and which sides are corresponding. So like, for example, I have shape ABCD is similar to shape WXYZ. So that means A and W are congruent angles. And then that means that B and X are congruent angles. It also means then that my sides AB goes with my side WX. And so they should have a like proportion to, let's say, CD and YZ. So it's important. It matters what order these letters are put in. That's kind of what I'm getting at here. It matters the order. The order matters. All right, we've done a lot of vocab. And so now let's put this into practice. Let's see what's going actually on with this. So the first example says, given that triangle RST is similar to triangle XYZ, complete the following. So it is important that my vertices are in this right order, and I made sure to label it accordingly. So R and X, since they were written first, they are congruent angles and they both have just one little mark. Similarly with S and y, they are the second angle, and they both have two little congruent marks to show me they're congruent, and then vice versa for z and t. Okay. Letter A says, find the scale factor of RST to XYZ. That means when I do my scale factor, I want triangle RST to go on top, and I want triangle XYZ to go on the bottom. So since I said find it of RST to XYZ, we have to start with RST. And it doesn't matter, we just have to find two sides that correspond with each other, and we're going to use those to identify this. I have given you all of the sides in triangle RST, but we only have one side in XYZ, and that's XY. So I have to go back and decide which segment goes with XY. And in this case, it's RS. So technically I'm looking at side RS compared to side XY. If RS is 15 RS is 20 and XY is 15, that's my ratio, but I want to get it as simple as possible. So 20 over 15, I can simplify that all the way down to 4 over 3. And so my scale factor from RST to XYZ is 4 to 3. Anybody have any questions yet? Okay, the next problem looks almost identical. It just says find the scale factor of triangle XYZ to triangle RST. So it's the exact same thing, but just flipped. Instead of starting with RST, we're going to start with XYZ and then go to RST, which means instead of starting at 20, we're going to start with 15 and go to 20. It just means that my scale factor is flipped. I go 3 to 4 instead of 4 to 3. So because those are opposite of each other, it matters which way you're going. If I ask for the first one, the answer 3, 4 is not a correct answer. The answer 4, 3 is the only correct answer there. Okay, it's important to be able to find the scale factor because we need that for the rest of these problems. So letter C says find the value of X using a proportion. It truly doesn't matter which one we use. We just have to be consistent with which one we're going to use. So I have to find X. And X, Y, Z, that side, I go from angle 2 to angle 3 or Y to Z. So that goes with TS. So I have 16 and X go together. You can set this up one of two ways. So the first way is if I use the first scale factor. If I go from triangle RST to XY, that means I would have 4 over 3 equals 16 over X. If you would rather go the other way, maybe we want to go from XY to RST. So maybe I'm going to go from 3 over 4 to the other way. Then that would mean it's X over 16. It truly doesn't matter because look, if I cross multiply, I've got 4 times X equals 3 times 16. And that's the same thing when I have my other equation, 4 times X equals 3 times 16. Either way, I get 4X equals 3 times 16 is 48. And then X equals 12. So both ways to set up are correct because you end up going to the same answer that's correct. Okay, questions yet? Okay, letter D says write a proportion that relates the corresponding sides. So that means I'm going to write fractions that compare all of my sides. And it doesn't matter which order we go from. I'm just going to mimic what we did at the beginning. This, if I had stopped here, that is what I'm talking about for letter D. That's writing a proportion that relates to corresponding sides. So I'm actually going to start there. I'm going to say triangle RST goes with triangle XYZ. And that just helps me keep in order what is going on top and what's going on bottom. And so the first set of sides that goes together is RS and XY. Can someone give me another set of sides that goes together? Oh, sorry. What's another set of sides that goes together?
Could YZ and ST be one?
Yep. I am going to put ST on top though, because that's what we've been doing on all of these. So ST and YZ. Very good. And then I can think of one more set.
TR and ZX.
TR and ZX. Good. I like how careful you were with wording those. TR and then ZX. And these are the only three that we need. If you wanted to kind of shuffle the letters, I just like how careful we were with the last one. So we could have said RT, but then that meant my bottom would be XZ. So we just got to make sure the letters match in all of these. And so those are my proportions that relate my corresponding sides. Good job. Anybody questions yet? Okay, let's go down and do an example. So the next one says, determine whether the figures are similar. If they are similar, find a scale factor of WXYZ to PQRS and write a similarity statement. So the first thing I decide if all the figures are similar is to see, are all their angles congruent? Okay, I go through and I see W has 1 mark, P also has 1 mark. So those angles are congruent. Then I see, okay, Z and S both have 2 marks. Okay. I see Y and R have 3 marks. Oh, I wanted a different color. Y and R have 3 marks. And then the last one, X and Q have 2 marks or 4 marks. So yes, they all the angles are congruent. They all correspond together. And I can even go back to the beginning and make sure it was written the right way. So P and W go together, they're both first, then X and Q, then R and Y, and then Z and S. Perfect. Okay, that's true. Now I'm going to see if all the sides are proportional. I have measures for all the sides, so now it's my job to match them up with the right ones. So just like I had highlighted my angles, I'm going to essentially do that with my sides, and we're going to see if those are going to give me the same thing. This is nice because they're like written right next to each other. So like whatever's on like the left side goes with the left side, whatever's on the top goes with the top, etc. Pretty easy to decide which are corresponding sides. So my first set is, okay, I'm going to think about, okay, is 9/6. Wonder what that is as a simplified ratio. So 9 divided by 6, I can take a 3 out of both. So I get 3/2. Okay, perfect. I'm going to try that for all of these. So the next one I'll do is 12/8. See if that simplifies down to 3/2. I can take a 4 out. Okay, good. We're doing good so far. Now I'm going to try 18 and 12. I can take a 6 out of both. Okay, so that gives me 3/2. Awesome. And the last one, 15 and 10. Take a 5 out of both, so 3/2. Oh, nice. All of these corresponding sides have the same simplified proportion, 3/2, 3/2, 3/2. So yes, their sides are proportional. I would say yes, these are similar. And I'd say my scale factor is 3/2. And the last thing it says is write a similarity statement. And you can put them in whatever order you want them to be. And we just need to make sure the angles match up. And you don't have to do anything crazy. You can literally take what they told you. So we knew from the beginning this was already written in the right order. W goes with P, Z goes with S, et cetera, et cetera. So I'm just going to write it in that order. A similarity statement is where you write the 2 shapes with a little similar sign between them. So I checked to make sure their angles were congruent. I checked to see if their sides were proportional. Both of those were true. So I found the scale factor and I wrote my similarity statement. All right, anybody any questions yet? Okay, so that problem was asking, decide whether they are similar. It's similar, question mark. The next example tells me they're similar. This one says similar, period. We know that they're similar. Now it says find X. So if these triangles are similar, then I have sides that are not congruent, but proportional. So I'm going to make a proportion. I've got one fraction equals another fraction. And we're gonna fill that in using the numbers that I have. Okay, so I know I've got 6 is AB. Does anyone know which side in DEF goes with AB? What am I gonna write?
3.
ED. DE. Sorry.
Good, DE, I heard that. And then I think I heard someone say X minus 3 too. So both the same way of writing the same part. So I can say 6 goes on top and I can say X minus 3 DE goes on bottom. The next one is the exact same, and there's only one other side, so I'm not going to make you kind of guess on this. You should already know that 12 and X plus 1 then go together. You could also, I know some people like to write it in one shape. They like to do 12 over or 6 over 12 and then do your X minus 3 over your X plus 1. That's still okay because when we cross multiply, we're still doing 6 times X plus 1 and 12 times X minus 3. So if you had written it that way, you should still get the same answer as I am going to get. Now, once we set that up, now we're going to cross multiply and we're going to solve. 6 times X minus 1, X minus 3 times 12. I like to be really careful. So I like to write 6 times X minus or X plus 1 and 12 times X minus 3 and then distribute. I'm afraid of losing something or not distributing my 6 or my 12 through appropriately. So I'm trying to be careful. So I get 6x plus 6 equals 12x minus 36. We're going to get our x's together. So I say minus 6x. I like to, in the same step, move my 36 over 2. You can do that as a separate step or you can do it all together. That gives me 42 equals 6. And when we divide by 6, x equals 7. And all it says is find the value of x. And so I don't need to go any further than that. If you want to plug it in, we could plug 7 in for both my x's. And I would see that that orange side becomes 8 and this green side becomes 4. And so then I could ask myself just to check my work, okay, is 6 over 4? Well, that simplifies down to 3 over 2. If I did 12 over 8, does that also simplify down to 3 over 2? The answer is yes. So that's just me double checking my work. All right, any questions yet? Any thoughts? Okay, let's flip our paper over. I essentially have I literally have 2 examples back here. Just one of them has like all of these pieces to it. So the example says if quadrilateral ABCD is similar to quadrilateral EFGH, find the following. So they told us they are similar. Yes, they are similar. Now we're just using that information. Okay, so we want to find the scale factor of ABCD to EFGH. What I would do as soon as you know that angles are triangles and quadrilaterals and shapes are similar, I would mark all the angles that match up together. So I'm going to mark angle A and angle E both have like one little congruent mark because they go together. I'm going to do B has 2 and F has 2. G is going to have 3 and C is going to have 3. And then H has 4 and D has 4. That helps me see what is given to me. And I see that these shapes are just like kind of direct images, like literally copied and pasted right next to each other. So that helps me keep in mind what my like parts are and what I see. I also am going to point out that this looks confusing, but my DA side, that says 8. And then my HE side says 6. So the way this printed, the 6 and 8 look super similar. So make sure that they look different enough on your paper. I needed to point that out because in order to find the scale factor of ABCD to EFG, I have to use 8 and 6 because there's no other sides given to me in EFGH. Since I want to go from ABCD to EFGH, I have to start with ABCD, which means I'm starting with DA and then I'm going to HE. So DA is 8 and HE is 6, and we're going to simplify that down. I think I can only divide by 2, so 8 over 6 equals 4 over 3. All right, now it says that we need to find my other sides. I have to find EF, I have to find FG, and I need to find GH. So I'm just going to make this easy. I'm going to label X, Y, and Z, and I'm going to set up a proportion. My proportion, or my first ratio at least, is 4/3, which means that I'm going from the first box to the second. And so as long as I set up all my proportions that way with my variable in the bottom, then I'm going to be good to go. So to find EF, that means I'm finding X. So I'm going to do 20 and X. So 4/3 equals 20/X. My proportion, my scale factor came from going from ABCD to EFGH. So I'm going to start with 20 and I'm going to go to X and I'm going to cross multiply and solve. I get 4X equals 60, X equals 15. All right, now I'm going to go label my picture. I'll keep my X there, but I will just write 15 over it or next to it or something along those lines. Maybe X equals 15, just so I kind of know what I'm doing. Now I'm going to go find Y. So now I'm doing 12/Y. Still using my scale factor. 4/3 equals 12/Y. Going to cross multiply. I get 4Y equals 36. I take 36, I divide it by Y, and I get 12. Gonna go label my picture.
How did you get 12?
Oh, sorry, why did I get 12? Is that 9? I'm so
Yeah.
sorry.
Okay.
Thanks,
I was
Rose.
confused.
I'm just tripping. It's 9. All right, last one I'm gonna do is 25 and Z. So same thing, set it up. 25/Z. I'm gonna cross multiply and I get 4Z equals 75. I will tell you this will be a decimal, and we often see a decimal, we just start panicking. We should get 18.75. And just because you got a decimal doesn't mean you're wrong. It's a proportion. So in order for it to be a 4:3 ratio, sometimes you end up getting a decimal, and that's okay. So just because you get a 0.5 or a 0.75 or a 0.25 doesn't necessarily mean that you're wrong. So I'm going to go up here and label my Z as 18.75. So by finding my scale factor and setting up a bunch of tiny proportions, I was able to find all the sides of my shape. Anybody have any questions yet? Okay. The next like 4 that I'm doing is kind of building us up to like another property, I guess, of our similar shapes. So it says find the perimeter of ABCD, find the perimeter of EFGH. So go ahead, take a second, find your perimeters, and then find the ratio of the perimeter of ABCD to the perimeter of EFGH. So take a second, I'll catch up with you in a second. That gives me 65. And that gives me 8. Okay, so once you find your ratio, your perimeters, I got 65 and I got 48.75. Now I want to find the ratio of the perimeter from ABCD to the perimeter of EFGH. So ABCD is 65, perimeter of EFGH is 48.75. Okay, normally we would just like divide by a whole number and figure out what my ratio is. I can't do that though with these decimals, so I'm going to put it in the calculator. Let me just do that really quick. And this takes a little bit of math sense. So every year, sometimes we're a little confused on this, but we're just going to use our math sense. So I'm going to do 65 divided by 48.75. Oh, that's the wrong one. Okay. And I get 1.333333 repeating. Okay. Now, if you've noticed, none of our ratios are written as a decimal. They're always written as a fraction. So we have to think about what would this be as a fraction? This is 1 1/3. So like 1 1/3. Well, that's the same thing as 4/3. And if I'm not sure and I want to check myself, I'm going to do 4 divided by 3 in my calculator and I get the exact same thing out. So based on what I know about this repeating decimal, 1.33 is 1 1/3, and that's the same thing as 4/3. Now that's funny because my scale factor was 4/3 or 4/3 a minute ago. So the cool thing, the conclusion I'm trying to reach is that if two polygons are similar, then the ratio of their perimeter equals the scale factor or the ratio of their sides. So whatever scale factor you had for like each individual side also goes for your perimeters. So now we're going to be able to use that concept in the future with just perimeters. Does anybody have any questions on how we worked our way up to that point? Okay, we got one more problem to do, and then we are done for today. This one says if triangle DEF is congruent to triangle GHJ, find the scale factor of DEF to GHJ and the perimeter of each triangle. Okay, so I'm actually going to do this in a way that I don't find all the missing sides. I can identify the perimeter right now of DEF. I can add 10 plus 8 plus 12. If my mental math isn't working this morning, I got my handy calculator, and that equals 30. I also know that they're similar, so I'm going to find the scale factor between those two shapes. It looks like the only two sides that I have are 8 and 12. So I'm going to do triangle DEF compared to triangle GHJ. So that is 8 to 12. And we're going to simplify that. They both are divisible by 4, so that gets me a 2 to 3 ratio. Okay. Now I have my scale factor, and what we just learned a minute ago is that if polygons are similar, then the ratio of their perimeter equals the scale factor. So I can use my scale factor in the one perimeter I have and solve for the missing perimeter. So I'm going to do 2/3. That was triangle DEF over triangle GHJ. And so the perimeter I do know is DEF, so that goes on top, and X goes in the denominator. Cross multiply and solve. I get 2X equals 90, and divide 90 by 2, and I get 45. What that means is 45 is my perimeter of triangle GHJ. Okay, that is all the notes that I have planned for today. Does anyone have any questions? Okay, this is my last reminder. Make sure that your homework for today, your 7-1, gets turned in, and then you are all responsible for 7-2 for the next class. Let's go look at what that is, because we're going to skip a few pages in our homework packet. So you were supposed to do the first 2 sides for homework for tonight. Then we did a couple random problems on the 3rd and the 4th page. The 5th and the 6th page still say 7-1. So your homework tonight is the one that says 7-2. And it has like 6 problems of just shapes on the first side. And then on the back side is 4 quadratic formula problems. I will make sure this is linked on the, like on your Schoology page if you want to double check which 2 sides to do. Excuse me. But I'm telling those of you who are here now, and then anybody who's watching this back on YouTube later, do the front side that says 7-2, and then its back side is 4 quadratic formula problems. Okay. All right, I'm gonna stop my record